So today we're going to find the volume of prisms and cylinders, and the first thing to consider about volume is the amount of material I can fit inside. So if I were going to fill this thing with water, how much water did I just use? Now, if I wanted to talk about surface area, then surface area is going to be how much material I use around, how much cardboard I use to make it, etc. So is side times side times side. So that'll tell you how much fits inside a cube. Now in this case, of course, we just recognize this is a mental exercise here. We just recognize that the side is 4. So the volume being side cubed, all I do is say 4 cubed, and in this case 64. And how do I write units? I have to do cubes, so inches cubed. Inches cubed. All right, so this one here, no big deal. We recognize the side as 6, and our volume is side cubed, and 6 cubed, of course, is 216 centimeters cubed. Now, volume has a lot more simple equation than surface area. Surface area was this plus this plus this plus this. We added up all these things together to come up with 2b plus pH or something like that. Volume is a lot more simple. Pretty much volume is just the area of your base times your height. So remember that capital B, and this is for a prism, capital B means area of the base. So again, one of the most important parts is for us to find and identify which shape is my base, because capital B formula is going to change based on what the area of the base is. So we're going to be using this formula, and this works for any prism, and it even works for a cube if you don't want to remember S cubed. All right, so part of this is mental, shape of the base, and in this case we have options. So if I decide to call this my shape, my base, that's the bottom and the top, then the shape of the base here is a rectangle. Then the area of the base is going to be length times width. So in this case, it's going to be 4 times the 13. Notice perimeter's not necessary in this formula, and we just multiply that out to get 52. I'll deal with the centimeters at the end. The height, of course, means the distance between the bases. So this one here will be my height. All right, so, and that's just a quick identification. So now we can plug and play things in. Remember, best if you start with the formula, just so that you have a good memory built in, study built in, and multiply that by 5 to get the final answer. My answer is going to be in centimeters, and that's a cube. Centimeters cubed. Again, how do we check our estimate? Well, cubic is so large that it's hard for us to quickly assess that until we have lots of familiarity with it. So what's the difference between 1 and 2? What type of base are we dealing with in 2? On number 2, we have a slightly different scenario. Here my base is the front and the back, the triangle, like so. So in this case, I have a triangle. And to find the area of this triangle, I'm going to use 1/2 length times width, or 1/2 base times height. Of course, my length and my width, here I'll call my length, and here I'll call my width. The key is that they are perpendicular to each other. So when I plug those in, I get 1/2 6 times 4, which clearly is 12. And now we recognize the height as 1, the distance between is going to be 1 foot. And now we can plug and play. Volume of any prism is capital B times H. So now I plug in 12 and a 1 to get 12 cubic 12 cubic feet. And the last one should be number 3, not number 2. So look at this here. The shape of my base is the trapezoid, hanging out there in the front, hanging out there. So I have to use a trapezoidal formula. So in this case, to find B, we have to take the average of the bases and multiply by the height of the trapezoid, not the height of the prism. So over here, my bases are this 11 and the 5. Why? Because the 5 is also over there. And then the height of the trapezoid is 6. So this is the height of the trapezoid. Over here is the height of the prism. So we're going from 2 dimensions to 3 dimensions, so the h's are different here. So I'm going to use the 5, 11, and 6 over here. So B equals 1/2, 5 plus 11, and the 6 is the height of the trapezoid. So 48 is what we get there. We already said that the height of the prism was 3. So now we just plug and play. Base times height, or area of the base times height, and simply 48 times 3, which is 144 inches cubed. So for each problem that we're looking at here, we have to assess what's the shape of my base, and notice my formula is going to keep changing in these cases. Here I used length times width, here I used half length times width, here I used trapezoidal. It could be a hexagon, so we could be using area is 1/2 AP. So just depending on that, this will change every single time. Height is always the distance between the bases, and we just plug in B and H. So it's similar in process, but actually much faster. We don't have to deal with perimeter. We don't have to deal with, that's it actually. So one application of this is to find out what the area, or excuse me, cubic, or the volume, cubic feet of water fits inside a pool. And then we can convert that to gallons momentarily. So the first thing to recognize is that my capital B is a trapezoid. So I'm going to use a trapezoidal formula. So notice that my bases are 10 and 4. So 1/2, 10 plus 4. And height is going to be 30. Why? Because that is the height of the trapezoid there. So in the end here we get 210 square feet. All right, now the height of my swimming pool here is actually the distance between the bases, so that's 15. So the volume is going to be capital B times H, which is 210 times 15 to get exactly 3150 cubic feet. How many gallons in a cubic foot?
Let's see. 1 cubic foot converts to about 7.48 gallons.
So, accordingly, 1 gallon is approximately 0.134 cubic feet. So, in other words, there's about 7 gallons per cubic foot. So when we take what we just got, the 3150, we divide that by 0.134, we're going to get approximately 23,507 gallons. Now the question doesn't actually ask how many gallons it holds. It just says find the volume of water. So 3150 cubic feet is fine. However, we don't think in cubic feet. We usually think in gallons. So I did the conversion to gallons to get 23,000 gallons. So going to Sam's Club, getting 23,000 gallons of milk, and then filling your pool up, that is going to give us a perspective on how much water is in there.